that. So that would be like, that would be cutting my little string up and 0.15, because it's definitely not 0.25, right? That's 25% of my string. That's not going to cut it. How about this? Would it be something like, let me toss out a number there to you. What about 0.14159265 blah 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 blah? Would that fit? Let me go back and say it again. What about this decimal, or this fraction? 0.14159265 blah 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 blah. Where have you heard that number before? You heard that number. You were told to memorize this number that goes on forever and ever and ever. Oh, what? Okay, so hold up. Your whole life you were told when it comes to circles there's equations and 2 pi r and blah blah blah. And your teacher told you pi has a number that's in like infinity. It goes on forever. 3.14 blah 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 blah. Have they ever told you the importance of it? No. So that's what we're here in my class, because I love learning about the importance of it. So let's go back real quick, looking at my circle. I'm going to put my circle over here, and I'm going to make it so that way hopefully we can see the whole circle. There we go. So you were taught the word pi, P-I, and that number is a memorized number at 3.14. But I want to explain what it means to you a little bit better. So when you were taught pi, which is what is 1 pi regarding a circle, which is a half of a circle? What is 2 pi? A full circle, okay? So if I got my string and I chopped it for the radius, right? And I wrapped it around, I was able to make 1 piece of the pie, 2 pieces, 3 pieces, and I have a little extra. How much extra? 0.14 blah, 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 extra. So when Morris over here, her eyes are closed. I just want to blow your mind away in my class, but it's so much better in person than it is online with me. So when you were taught pi, which is 3, 1, 2, 3.14, that's where they get pi from. But wait a minute. Did your teachers tell you that pi 3.14 is only utilized for medium-sized circles, not the big or the small ones? Did they tell you that? No? What did they tell you, Cameron?
I haven't heard that at all.
What about pi? When do we use pi for 2 pi r or blah, blah, blah pi? What kind of circles do we use them for? Exact circles. Is it a particularly medium or small or extra large? Doesn't matter what size. Does not matter. So it doesn't matter. I can get the smallest circle or the biggest circle. As long as it's an exact perfect circle, it will always make 1, 2, 3.14 pi. Same thing. 1, 2, 3.14, which is 2 pi's now. 1 pi, 2 pi's. So now, let's put it together, and we're solidifying it now. When I tell you that the lizard traveled 3 feet, your mind, 1, 2, 3. But when I tell you that that lizard traveled 3.14 rads, that means a half a circle. When that lizard traveled 1 pi, that means a half a circle. When the lizard traveled 6.28 rads, that means it traveled through 1 full circle. Make sense? That's how we talk in physics. Ooh, I love it. This is my favorite though. All right, every unit there's always my favorite, but here we go. Now it says on your lab paper, go ahead, and we wrote yes for number 13. 0.14159 da 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 da. And I think it's so cute for those people who memorize it and they think they're just amazing, but do they really know what pi means? No. They memorized a fact, but they didn't know what it stood for. Let's keep going. Number 14. Go ahead in red, write 0.14 radians, because that's what this is right here. 0.14 radian. And in green, go ahead and find your degrees. Theoretically, if all of this is 180, if I got 57, 58, 57, add them together and subtract from 180, I should know what that is, right? So in this part, go ahead and give me the theoretical now. Now I'm gonna be lazy. Now that we did the other pieces of the pie, I'm going to, on my calculator, I'm gonna go ahead and I'm gonna add 57 plus 58 plus 57 equals, and I'm gonna subtract 180, and I got 8 degrees. So that little piece of the pie is 8 degrees. Go ahead and write that on your lab paper. That's like number 14, I think. Right here, number 14. 8 for me. I don't know what you got. So number 15 says, I'm going to move this out of the way real quick. Now look at half of the plates that you just made. How many radians are in a half a plate? 3.14. Number 16. What is that also called? Pi. Now number 17. Now starting at 180 degrees, this is where most students make a mistake. Starting at 180 degrees, complete the bottom half just like you did the top. But hold on, we're not gonna do it today, you're gonna do this for homework. And you're gonna make radian 4, 5, and 6, and 0.14 radians. But you're gonna do this for homework later, okay, because we don't have the time. But we know what to do now. Where do we start? We start down here at 180. Oh man, Ms. Munson, I started over here on the red line. Why? We already accounted for that little line, right? That section. So start at 180 degrees, and you're gonna make your way all the way around, and you're gonna make radian number 4, radian number 5, radian number 6, and then you're gonna do 0.14 radian, okay? Here's the kind of teacher I am, okay? I don't like us to do shortcuts because I feel like truly for anything in life, the only way to get to the end and get better is by doing it. So I'm gonna expect you to use your strength and actually use a protractor and measure every single section. What do you mean, Ms. Munson? How is she gonna know? Because when I grade this lab, I take home my protractor and I pick 1 radian. It might be 4, it might be 5, it might be 6, it might be not the extra, I won't do the extra. But I'm gonna do one of them, and I'm gonna do the same one for every single student, and I'm just gonna measure that 1 radian. And if it really is 55 degrees and you just wrote it down, you wrote down 57, 58, 57 because you were lazy, then it's gonna be wrong. This half is wrong then, okay? So I told you how I grade this paper because I feel like the only way to get better is to do things over and over and over. All right, well, I'm moving this out the way. That's number 17. But let's go to number 18. Now that you completed the paper plate, let's do this for other size circles. So that's why we have big ones, small ones, medium-sized circles, okay? To prove to you that I'm not lying, because I don't want you to ever take my word don't just take my word. Don't take anybody's word. Don't just memorize what pi means because my teacher told me to when I was in 5th grade. What? Ask. Figure it out. Why is it? What does this stuff mean that you're teaching me? What is the depth of it? Let's get into the details. Okay, so do it on another circle all the way, Miss Munson? Yes. Your circle paper needs to look just like your plate. It needs to have the quarters, right? It needs to start off with 0, 90, 180. It's going to have all the radians. Could I cut it out? You're more than welcome to cut the circle out later on whenever you get a chance, or if you want to leave it as a whole paper, your choice. So for your lab grade, you've got to turn in the paper plate, and the paper circle. The lab paper, the paper plate, and the paper circle. How do I grade it? I pick 1 radian on the paper plate, I pick 1 radian on the circle, and it's the same one for every single student, right? Because I like to make things as fair as possible. And then I grade your lab paper. Now let's look at the bottom of the lab paper. Using your paper plate. In physics, we like to put things into charts because it's so much easier to analyze data that way. So on your paper plate, what was your radian what was your degrees? For me, it was 57 degrees for my theta. What was radian number 2? 58. Radian number 3, 57. The extra was 8 degrees. And then you're going to finish it, and then you're going to do the same thing for the paper circle, if that makes sense. So I think this lab is so much better to do in person than it is to do online. Okay? Now, let's turn the page. Everything here and on the next page, okay, we're gonna go over in our notes. Now, I want to stop real quick and I'll show you in our notes what we're gonna do. But when you get over here to this is calculus unit circle. This is not physics unit circle. So how do I do this then, Miss Munson? Oh my God, I can't answer this, child. That's the 3rd time the same question. Y'all wonder why I go insane. I sent out a day, but when you ask me the 3rd time, I start to freak out. It's like, Mom, where's the ketchup? I told you it was on the 2nd shelf. Don't ask me again. Let's go. So this part is calculus. Okay, but if you stop for a moment and think about this, this is really a 1 in front of the pi sign. Okay, some of us kind of get thrown off. You know, I don't like fractions to start off with personally, but that's 1 pi over 4. Okay, and I'll explain this part in just a moment. But let's get to our notes so this can make a little bit more sense. Okay, so in our notes, you got your notes out. Back to our notes. Now that we know how in physics we talk about distance regarding a circle, you can go to calculus or somewhere else and they'll talk about ellipticals or something else. That's not me. But let's go ahead and define, what does that word radian mean? The word radian, well, if I had to put it into words for you, it's like the length of the radius, of the radius, I misspelled it, there you go, comma, on the circumference, oops, I misspelled that one, of a circle. Did I say medium-sized circles? No. Small circles? No. Any circle. So the length of the radius, right? That's what we got our piece of string, around the circumference of the circle. And how many times does that piece of string fit around 180 degrees? 3.14 rad. Because that's the SI unit, a rad, or radian. What do we call this number? Well, we call it pi. And how many times will a rad fit around 360? 6.28 rads. Does that make sense? Hopefully it does now. What is the formula for calculating the circumference of the circle? Well, 2 pi r, and we use that same part, we use part of that with our velocity equation that was on the other page. Now, Or how does this compare to the number of radians it's gonna fit around the circumference? They're the exact same. 2 pi r is exactly the same of going around that circle. Now, here's another word that we need to pay attention, because you might see a quiz, you might see a test, you might see it homework, okay? When they use the word pi radian, that is different from the word radian, okay? Pi radian. So when they use the word pi radian, they're talking about a half a circle. Pi radian. But when they use the word radian or rad, then they're only talking about one piece of the pie, okay? So pi radians is talking about pi, a half a circle. When they use the word radians, they're only talking about one piece of the pie. That's it, one little section is what a radian is. So let's look at this. How many pi radians are in one rotation around a circle? One rotation around a circle. This is pi radian. How many of these? 2. One in the top half, one in the bottom half. 2. Here we go, because this is confusing too, and I screw up on questions because I don't pay attention personally, because I just run and rush through things. I'm one of those people. I just rush through it and I don't pay attention. So I'm gonna put right here a little line, and I'm gonna put pi radians is a half a circle. And that makes sense, which is a pi. Radians is one section of PIE. That's gonna make sense to me. One section of the pie, like one section of pizza is what that is. So sometimes I just like to write a little bit of notes on the side because I'm not always gonna be there for you. But if you're like Miss Moore, she doesn't mind if I call her at 10 o'clock at night. She's like, I'm up. I'm like, okay, me too. All right, let's keep going. How many radians are in one rotation around a circle? 6.28 rads. How many pi radians are around 2 rotations of a circle? I agree, 4 is what Cameron says. Okay, well then how many radians are in 2 full rotations? Elena's thinking, I see her thinking. She did that little thinking. I know it's 12, because 6 times 2 is 12. And this is 28, so 28 times 2. So what, say it again? 6. 56, okay. If 2 pi radians fit into one complete rotation, correct? Around any circle, how many pi's radians would there be in 6 rotations? So 1, 2, 3, 4, 5, 6. I am a visual person. So for this section of the notes, or this section overall, I'm probably gonna be doing a lot of circle drawings, right? You saw that one in the video when I was doing that, my math. Same thing here. I did 6 rotations. How many pi's are in one rotation? 2, 12, 4, 6, 8, 10, 12. I agree. So how many rads are in 4 pi radians? How many rads, which are just the word radian, are in 4 pi radians? What is, say it again, Cameron? 6.28 rads. Because 4 pi radians, here's 1, here's 2, here's 3, Here's 4. That's where he got it. Wait a minute. Cameron?
Shouldn't that be doubles?
Yeah, shouldn't it be double? I was like, wait a minute, thank you, Aiden. I was like, wait a minute, Cameron,
Did I miss it?
yeah,
Oh.
that's okay. Hey, I'm human. I wrote it down. 12.56 rats. Look, 1, 2, 3, 4. I even drew out the circles and I still screwed it up, sorry. So, hopefully this makes a little bit more sense, okay? The word pie rats and rats are 2 different things. And I really like to do this paper circle with you because I think it brings it to a whole new light. Now, okay, so let's keep going. Let's do a little math now. Now, when we're converting degrees to radians, you're going to multiply it by pi and divide by 180. This is an equation you use in pre-cal. If you're converting from radians to degrees, you multiply it by 180 and divide by pi. So let's come over here and practice this. I've got 225 degrees. Now hold up. This is what I like this for, because now I'm a visual person. 225 degrees. If this is 0, and this is 180, and this is 270, where's 225? About here? So before you get your calculator out, visual person, how many rads, if my lizard started here and it's going to walk 225 degrees, about how many rads did my lizard go? About 4-ish. Make sense? Without even having to get your calculator out. Okay? So maybe having this may help you do some of your work. Okay? So have this finished when you're doing your lab. So let's go ahead and let's do that. 225, Miss Moore has her calculator out. Multiply it. Now, which equation? We're using the top one. Multiply it by pi and divide by 180. What did you get?
I got 3.92.
3.9?
3.93, sorry, I did not write.
3.93. Now, and that's pretty close to 4. That's pretty much almost 4-ish. Now, did you do it in degrees or radians? What mode did you have?
I've been having it on radians since we started this unit.
Because what did I say in the video?
That we need it in radians.
We need it in radians. So in the video, make sure that it's always in radians. Now, let's come over here. And again, this is how you're going to see it in calculus and pre-cal, math class, okay? In physics class, we normally don't see it like that, but that's okay. Again, I'm a visual person. This is my rads, and I need to go to degrees. So I'm going to use this equation. 5 pi over r times 180 over pi. Do you see how the pi's cancel out? So 5 times 180 divided by 9 is going to give you the degrees. What is that more?
I got 100.
100 degrees, that is true. So 5 over 9, 5 pi over 9, which is 100 degrees, which is about here. So 5/9 of the pi. Now remember, the pi is only half a circle. So about to here, which makes sense. All right, let's go ahead and turn the page and let's keep going. And I'd like to go over this page in your notes, which is similar to your homework, which is similar to your lab, which is, I promise you, you're gonna have some questions like this on the test where you're gonna have a protractor. So either you use your own protractor, my protractor, or paper protractor on the test day, okay? So on here, the #1 question that I get from students, so do not email me and message this to me because I'm telling you now. Question, or the email says, Miss Munson, I can't do the question, I can't do it. Or when students come to class, when I see them every day, and I'm over here and I'm like, hey, did you get your home? I couldn't do that question. Why can't you do it? Well, because the line's too small. What do you mean the line is too small? So this is what I get from students every single year. So let's look at this. This line right here, Miss Munson, it's too small and I can't measure it. Well, what'd you do? I didn't do anything. You just sit at home and not do any work at all because the line was too small. Can I problem solve for y'all real quick? Look at this. Get your ruler, which I'm gonna use my protractor because it's over there. Come over here. Draw it out. Extend it. I also need to have my 90 degrees for me, so that way I can have a reference point, so I draw out my 90 degrees. Look at that, problem solving. Karen's like, and you know what? What do I say to the kids at home? That's why I'm the mama and you're the kid. This mama can problem solve. So, this is 90 on my scale, and I've got 90 here, and I've got 55, 56. So the difference of that would be, I don't know, somebody.
34.
34?
Are we doing it from 90?
Whoa. Say it again.
Is that paper in the notes? 'Cause I don't have that.
It is, it's gonna be page 2. It's.
Mine just has.
I only have 4.
Okay, I'm using last year's notes, my bad. So is this exact problem that says
Yeah,
number
that's-
2?
yeah.
It is on there, okay, I'm so sorry. Okay, you're right, I'm using last year's. I took some work away from this year's notes. Okay, Austin is a nice guy. Why do you want to be argumentative with him?
Sorry.
He seems really nice. I mean, he's not very nice every time I screw up on his grades. Because as Mud said, he messed up only he's laughing, but it's true. I'm human, Austin. Thank goodness he's very kind though when he's like, you messed up again. Okay, so you want to argue with Austin?
What did Austin say? What?
Well, Austin said 34 degrees.
It
Okay.
said to find the difference, so I just put it in the calculator. Right.
Which he's a very, very polite kid.
It
But-
might be the difference, but it's not the actual degree. The degree, you have to add at least 90 more degrees, because if you're starting from 0 to that point, that would add up to 125 degrees instead of.
So you'd add it.
Let me
you'd add it to
listen.
the 90.
You think so? Let's listen to the other friends with. Elena, do you agree with more?
Yeah.
Why? Just because you're from Friendswood also?
No,
Good
because
start.
it's a bigger part of the circle.
Okay, so here's what I do this all the time, especially in class. I don't get to do it like online because, well, you know, it's not the same. But I will try my best to steer you, Austin, in the wrong direction on purpose. Because I need us to stop and tell me, Miss Munson, that's wrong. Why do you do that? Because I need us thinking. What did I say when we started off with the paper plate? When we do circles, when you do any circles, this is always 0 degrees, and you rotate counterclockwise. 90 degrees, 180 degrees, 270 degrees. Austin, you just did what I asked. That was it, Austin. I was being ugly on purpose. And wait, I'm gonna keep doing that all school year. We have a whole semester of this. Nevaeh, it might be you next. So here we go. If we start at 0, and this is 90, it has to be bigger than 90, and we stop here. So, Moore came up with a really quick solution. She said, well, just get 90 plus 34 and add them together, which is,
Well, I measured it on my own and I got 125, but if you were to do that one, that would be 124.
well, I'm gonna use Austin's number. Okay, not too bad. So I picked that question on purpose, and I do that on purpose because I'm purposely trying to steer y'all in the wrong direction. Because I don't know about y'all, but I learn from my mistakes. Right? So we're gonna make the mistakes here while we're in lecture and not while we are at home. Now, this one, number one, is really easy. That little one, that one's just going straight up, so that's 90. That one's easy. And then you're gonna go ahead and use that same equation from page 1 to find the radians, okay? The equation is on your formula chart, so you don't have to memorize any equations. I don't believe in memorizing equations. When you go to the real world, you have a little cheat sheet of all your equations and stuff, right? No need to memorize. Some teachers, Mr. Glebe, you have to memorize.
And pre-cal, I had to memorize the whole entire circle, and our quiz is to fill up the whole entire circle.
Same thing here when it comes to pre-cal. The math teachers make you memorize, which I think is stupid because they don't have it themselves, I'm sure. I'm sure they probably use it thinking, why do I have to memorize it if you don't? Here we go. Next thing, let's go through some problems because now we did this work, let's like utilize it in physics questions, okay? So the first question, again, I apologize because the screen is hard to see. If, am I wrong? Is my notes messed up here on the questions from your notes?
I got one.
Is that 1 and 2 and 3 the same?
Yes.
Yes.
Okay, I just want to make sure because, again, I apologize, this is last year's test. If a car circles a perfectly round track 3 times, how many radians did it transverse? The word transverse means how much did it travel through? Okay, so how many times? 3. 1, 2, 3. So if the car goes 3 times around, how many radians? So this one has 6.28, right, for one circle, and this one's 6.28, and this one's 6.28. Then how much do we have total?
18.84 routes.
I agree. Number 2, when you're, we're running out of time now. Yeah, y'all have class next?
Yes.
Yes, okay. Ooh. Okay, so I was able to go through all of these on the other classes. I will go ahead and I will video going over that, okay? So that way you'll have those. I'm so sorry, we're just a little bit shorter. So let me write myself a note for video this. I will post that on Blackboard. I will also probably send it to you on Teams as well, but I will definitely video that. Then, I did not do this question for any other students, okay? So I'm not gonna video this. You know what, I'll video it. I'll video it as well, post that, okay? The other thing is, remember on the little